All right, in this section, we're going to talk about something called an inscribed angle. Now, you guys have learned about central angles, first of all, so let's kind of recap on that. So a central angle would be something like this, where this is the center of your circle and you have an angle off of it. So if the vertex is at the center, we call this guy here a central angle. And then we also learned that, like, let's say this is 60 degrees. Then its intercepted arc, as we call it, this arc right here, is also 60 degrees. Okay, so we know central angles. Let's go ahead and look at inscribed angles now. Flip into our note sheet. So there's a couple theorems that we're going to learn about here, and then a few corollaries, which are just little sub-theorems. So let's first just define what an inscribed angle is. So, and you can pause this at any time if you need to write this down. I also recommend maybe having some highlighters handy or some colored pencils, something like that. But that helped me a lot in these notes. All right, so inscribed angle. So this is an angle whose vertex is on the circle, so not in the center, but on the circle, and whose sides contain chords of the circle. And remember, a chord is just a segment where its endpoints are on the circle. So right here, this line, it's going through the circle, but this part of it is a chord, and this part of it is a chord. So this first one that I have right here, this would be an example of an inscribed angle. So its vertex is on the circle, and its sides are chords, or they contain chords of the circle. All right, so these two over here would not be examples of inscribed angles. This one right here, its vertex is outside of the circle, not on it. This one over here, its vertex is on the circle, but it's got only one side that's a chord. This one's not a chord of the circle, it's out here. Okay, so we've got that defined. Let's take a look at our first theorem called the inscribed angle theorem. This is the most important one. All right, so this one says, if an angle is inscribed in a circle, then its measure is half the measure of its intercepted arc. All right, so let's take a look at our example right here. So we've got an inscribed angle. We know its intercepted arc is 60 degrees, just kind of made up a number there. So our inscribed angle right here is always going to be half of this measure. So this would be 30 degrees. Okay. So the central angle, if we had, like, let's say our center was right here, and we connected endpoints that were the same as this one. Oops. Can't draw straight lines. All right. So our central angle is always the exact same as this number. This would be 60 degrees. But as you can see, if you take this and you pull it back, it makes that angle skinnier, half as skinnier, right? Or half as skinny, I guess I would say. So this angle would be half this measure. I just kind of drew out another circle for an example, if you want to do the same thing. So you could have a situation like this, just another example. I've got a central angle drawn, and I've got an inscribed angle drawn, and they have the same endpoints. So if this is 90 degrees up here, this would also be 90 degrees, the central angle. This one, the inscribed angle, would be half of that, so 45 degrees. All right, so that is the biggest theorem in this section. Now, after that, we have what we call corollaries. There's 3 of them, and they're basically just things you can conclude because of that theorem. So let's take a look at our first one. You can pause this and write it down if you would like. Okay, so first corollary. Let's read it together first. It says, if 2 inscribed angles in a circle intercept the same arc or congruent arcs, then the angles are congruent. So let's look at the circle that you guys have on your paper. I just kind of drew a secondary one over here. So this is where I think it's helpful to have some highlighters, because on your paper, it just looks like a bunch of lines intersecting. So I highlighted one of my inscribed angles and then the other one in a different color. Okay, so notice they have the exact same endpoints right here. And this corollary says if 2 angles in a circle intercept the same arc, so they have the exact same intercepted arc. then of course that would mean this angle is congruent to this one. So again, I just kind of made up a number here, 100 degrees. That means this would be half of that, 50 degrees, and so would this one. So in the corollary, it says if they intercept the same arc or congruent arc. So I wanted to just draw a separate little picture of that over here. So they're not intercepting the same arc, but in this one here, these two inscribed angles are going to be the same because their intercepted marks are marked congruent. Okay, so let's say this was 30 degrees. Well, this would also be 30 degrees. And then these angles would be congruent at 15 degrees. Y'all can see my cut on my finger. Okay, let's go on to our second corollary. I can write that one down as well. Oops. All right, corollary 2 says, if an inscribed angle intercepts the endpoints of a semicircle, then the angle is a right angle. And this is something that's pretty obvious you could figure out on your own just from the theorem. So I highlighted the angle. On your paper, it just looks like there's a triangle in the circle. And this kind of doesn't look like it's on the circle, but it's supposed to be. So that is on the circle. So look at this as just an angle, okay, not a triangle. So I highlighted this angle right here. So it's saying if its endpoints are on a semicircle or on a diameter, well, that would make this intercepted arc 180 degrees, which means this angle would have to be a 90-degree angle. Every single time, it's going to be half that measure. That's all that corollary is saying. All right, and let's look at our last one now. Corollary 3. We'll do some highlighting together on this one. Get some colors here. I'm doing these ones. All right, so it says if a quadrilateral is inscribed in a circle, then opposite angles are supplementary. Always, always. All right, this is another one that you could figure out. So what it's saying is we've got a quadrilateral inscribed in the circle. When it says inscribed, that just means that all 4 of its vertices are on the circle. All right, so that means opposite angles here, those are always going to be supplementary, and these ones are always going to be supplementary, okay? And we can prove this using the theorem. Let's, instead of looking at this as a quadrilateral, let's highlight some parts and just make it look like two angles. So if I highlight this, there's an angle, right? Here's its endpoints. It's intercepting this arc over here. All right, cool. So I know this angle, this one right here, is going to be half of this measure. Okay, I'm going to highlight the one opposite it in yellow. Okay, so there's another angle. Here's its endpoints. That's where they meet. And here's its intercepted arc. Okay. So the corollary is saying that these are always going to add to 180. They're always going to be supplementary. And this kind of makes sense because you've got this arc right here and this one right here. Well, their 2 intercepted arcs make up the entire circle, 360 degrees. So it makes sense that these ones, which are half of their measure, would always add to half of that, 180 degrees. I could even show you with like a numeric example. Like if this blue part right here, let's say that was, I don't know, 200 degrees. Okay, let's say that's all you knew. Well, you could conclude that the rest of the circle is, well, 360 minus 200, so 160 degrees. That would be the yellow part. And then if you want to get their angle measurements from those arcs, look at the blue arc. Here's an inscribed angle. It's going to be half the measure of 200. So this angle would be 100 degrees. And then let's look at the yellow arc, which is 160. So its angle is going to be half that measure, so 80 degrees. So boom, there you can see these are always going to add to 180. Same with these ones, which works the same way. And that's it for the notes. We should be able to do some practice problems now.